Let's create a system that has no unique solution. How about if we start with, say, x plus 4y equals 12. I'm just making that one up. We'll call that equation 1. And let's get another equation for no unique solution. What we can do is, we know how to do this. We're going to pick a number, a multiple, and run it all the way through. Let's pick 2. Let's just double things. So we'll double this 1, we'll double the 4, and we'll double the 12. That'll give us no unique solution. So let's do that. So we're going to get 2x plus 8y equals 24. That'll be equation 2. And when we graph these lines, they are coincident. So these lines coincide. And because they coincide, they intersect in infinitely many points. What we want to do is we want to take a look at what these points look like. Is there a general form for these points? We can do this by solving one of the equations for one of the variables. So I think what we can do here is kind of easy to see that if we solve equation 1 for x, we can solve this easily without getting any fractions, right? We'll just subtract 4y from both sides and we'll get x equals negative 4y plus 12. No fractions, easy to work with. Let's do that. So solving equation 1 for x, we get x equals negative 4y plus 12. Now, we've got infinitely many choices for y. Whatever we choose for y, if we choose some point for y, some value for y, multiply it by negative 4, add 12, we'll get x. So the value of x depends on what we choose for y. So the value of x depends on the value that we choose for y. So what if we did this? Let's just do a few examples. What if we let y equal 0? If we did that, then x would be negative 4 times 0 plus 12, or x would be 12. If we let, say, y equal 1, then x would equal negative 4 times 1 plus 12. X would be negative 4 plus 12. X would be 8. So these are just two possibilities for y. So in the first case, if we chose 0 for y, we would get 12 for x. So we would get this point of intersection, 12, 0. In the second case, if we choose 1 for y, we would get 8 for x, and then we get this point of intersection. We would get 8 and 1. Now, we have infinitely many choices for y. These are just two of them, right? These are just two, the 0 and the 1. We have infinitely many choices. So what we'll do is we could let y be any number. And what we'll do is, to denote that, what we can do is this. We will let y equal some number, and instead of writing this, instead of writing any number, which is a little awkward, let's just assign a variable to it, or a value to it. Let y equal t. This letter t is pretty common. This is called a parameter, and that t stands for, it just represents any number at all. For example, we could let that t down here, if t was 0, we'd x is 12, and if t is equal to 1, we'll get the 8. Now, if we let y equal t, then x is going to be negative 4t plus 12. So here's what our ordered pairs look like. They look like this. Negative 4t plus 12 and t. Let's write another system that has no unique solution. How about if let's just pick anything here. How about if we go with, say, 3x plus 4y equals 16. I'm just making that one up. That's equation 1. And why don't we just let's double all these coefficients so that we get a system with no unique solution. So how about if we go with 6x plus 8y equals 32. That'll be equation 2. And why don't we try to solve, let's solve equation 1 for y this time. So here's equation 1. Here's equation 1. What we're going to do is subtract this 3x. So doing so will give us 4y is negative 3x plus 16. And now if we divide by 4, we will get y equals negative 3/4 x plus 16 divided by 4 is 4. So if we solve equation 1 for x, what we're going to do is we're going to subtract this 3x here. So that'll give us that 4y is negative 3x plus 16. Solve for x by dividing by that 4. So we'll get y equals negative 3/4 x, and 16 divided by 4 is that 4. So what we've got here now is that y depends on x. So what we've got is that the value of y depends on what value we choose for x. Let's just try a couple. We'll choose some nice values for x to make it work out nicely. Let's try this. If x is equal to 0, then, now I'm just picking 0 because it's easy to work with, then y is going to be negative 3/4 of that 0 plus 4. That goes to 0. Y is equal to 4. And then our solutions look like, well, our solution will be this ordered pair. 0 for x, 4 for y. Now let's try another value just to see what that looks like. What if x is equal to 4? Now I'm choosing 4 because it's easy. If I put that 4 into this x right here, the 4's will cancel and I don't have to work with fractions. So if x is equal to 4, then y is equal to negative 3/4 of that 4 plus 4, and those x's cancel, divide out. And y is equal to negative 3 plus 4. Y is equal to 1, and we get this ordered pair. 4 for x, 1 for y. So in general, if we let x equal any number, let's call it t, then y is equal to negative 3/4 of that t plus 4, and our ordered pairs look like this. T, negative 3/4 t plus 4.